Okay, good morning to all. So in this session, we are going to discuss about the different types of the electromagnetic relay. Okay, so in detail of the electromagnetic relay. So in the previous sessions, we have discussed about the relays, which are deal with the power system. Okay, so we are having the electromagnetic relays, and we're having the in that type, so we are having the armature protection. Okay, so armature type that we are discussing. Okay, so and another we're having the so magnetic induction relay. Okay, so moving coil, thermal coil, so magnetic attracted armature type relays. Okay, so that we have discussed. And so here let me go to the different type. Okay, so here we're having the attracted armature type. So here with the electromagnetic relays, so whenever the input is given, so here mainly input we are taking, there is a current. So how we are based on the time setting. Okay, so based upon the current setting limit. So based on the current setting limit, the electromagnetic relay. Okay, so these electromagnetic relay is what, so whenever the fault current, okay, so it try to plug more. Okay, so it try to release the coil. At that time it will give the signal to the trip coil. Okay, so similarly to the in the armature type also. Okay, and you can see detail in the here. So this is the attract armature type we are seeing. So this is attract armature type. So in the coil, okay, so the contacts are placed and electromagnetic, okay, and the spring will also play. So whenever the variation in that current, okay, so input current, so these electromagnetic, that is the induction base. Okay, so electromagnetic, the electromagnetic coils will release this coil. Okay, so due to that at the position, so the springs will be turned, then the contacts which are connected to the relay, that will be released. Okay, the operating contact that will be here, and this the magnetic frame will be placed, and the armature, that is the we are having the armature, the thing. But so here we are having the laminations. Okay, so lamination, and on that with the combined with the winding. Okay, so this winding, so it will limit the flux. Okay, so based up the flux variation, if the variation in the flux, then it will release the coil. Okay, then that will be contacted to the relay coils. Okay, so here is a relay coil, so that will given to the circuit breaker. So trip contact is nothing but here that will we are taking, that is a trip contact is nothing but circuit breaker contact. Okay, and so here we in Armature. So sorry. So we are having the different types of the protections. In that we have discussed, that is the electromagnetic type, and we having the another types also there. Okay, so that is the static relays. Okay, so microprocessor based numerical type relays. Okay, so and different type. So static relays. Okay, so before that, so just we go to the different types of electromagnetic relays. So in that we having the, okay, so we are discussing the architect arm. Now here's the another one, that is the plunger type. So this is the plunger, so we already discussed, just get in the Julie. So here's the coil will there, and is the piston. So this here the moving, is the moving contact, and is the fixed contact. Okay, so this solid and spring, so that will be connected to the contact. Okay, the spring will be released whenever the variation is the current. Okay, then it will be removed. Okay, the solution is away from the fixed current. Then this spring is connected to the input of the supply. Okay, so here the mechanical input. Okay, so that's the mechanical way. Okay, the spring is release the current. Okay, so so here the attracted. Okay, so attracted axially within the feed solenoid state. Okay, so here is the in between, inside only they are having the some electromagnetic. Okay, now we are having the attracted armature type, right? So how it will work? Okay, so based upon the flux variation and force variation. Okay, so the mechanical force produced by electromagnetic proportional to the flux induced square. Okay, and here's the mmf and reluctance that we have given, resistance we have. So how much voltage the force will be developed. Okay, so we'll discuss in this topic in detail in the separate class. Just we'll go for the types. Okay, so we're having the another type, that is a magnetic induction type. So that is a wattmeter, so energy meter type. Okay, so energy meter construction is similar to the here also the relay is same. Okay, so here the wattmeter type relay, so it consists of the two electromagnetic. Okay, so consists of the two electromagnetic, and here we're having which operates in the moving contact. Okay, here having the circuit, so is a moving contact we are seeing, and you have the two coils, that's a main winding and closer winding. Okay, so moving contacts were placed, and disc. Okay, so fixed contacts were placed. Okay, you can see these are fixed contacts, and so here is the fixed contacts. Okay, so is the closed circuit. So whenever the, so it is connected to the via CT. Okay, so current transformer which are connected, that is the signal for the input current. Okay, so based on that the induction. Okay, so here that will be what. So here the operations will full of the wattmeter type. Okay, so based on that the induction type relay. So here they're having the two flux. Okay, so that is the we're having the one main winding, another wire. Okay, so you can see here we're having the two windings, right? So here closed one. Okay, so main winding, and here's a closed secondary wire. So due to that, here we'll get the two types of the fluxes. Okay, so that's a phi 1 phi 2. Okay, so let we are considering that is a phi 1 and phi 2. Okay, so the two magnets induction type, so relay producing two alternating magnetic flux, the phi 1 phi, and here is the disk. Okay, so based on this heat rotation here, so how it will be one. Okay, so here both are the alternating flux, right? So here phi 1, that is the phi 1 sin omega t, and phi 2 is the another angle with the some angle omega t. Okay, so where phi 2 is the angle phi 1 at theta. Okay, so the current phi 1 produces the eddy current. So how much eddy currents we are producing. Okay, so here is the one is the non-inductive part, it is the inductive. So their current variations is there. So due to the flowing of the current in the rotating disc, okay, you can see how much torque is run. Okay, so here the force, okay, so the torque based upon the torque, here that will variations in this. Okay, so that is the phi 1 phi 2 variations that these try to rotate. Okay, so when the rotations is based on, okay, so I1 I2 is there. Okay, so I1 is directly proportional to phi 1 cos omega t, and I2, okay, so which is cos the electron. Okay, so these are the this eddy currents. Okay, so I1 it's nothing but the eddy currents which are produced on the cup. Okay, so disk which is placed in between the two magnets. Okay, so then it is causes the electromagnet, it can cause the flowing of that. Okay, so then it's tries to move. Okay, if uh, variations in the current. Okay, so suddenly if the current is raised from lower value to higher value. Okay, so suppose if the input, so if we consider, so for 33 kV line. Okay, so for 33 kV line we are having the oh, 20 to 20 amperes of current suppose. If it then if suddenly raises a predator value is about the 100 ampere, so it's in the coil. So what will happen, the electron current, okay, so flux is produced is also very, okay, due to that the torque also introduces variations. Okay, this torque causes the high rotations at that. Okay, then it will give the signal to the path. Okay, the signal is given to the moving contact. Okay, that giving the moving contact. Okay, so that is the variation. Okay, the speed is a predetermined value. Okay, so then it will goes to the release the to the trip contact. Okay, then the fault. Okay, so here it says that the fault is sensed by the electromagnets. Okay, then that signal given to the circuit breaker. That is the mainly, so based on the input of the current variations. Okay, so here disk variations will be there. So input current is varied, then the signal is generated. The flux also varies. So due to the flux variation, it will tries to move from higher speed. Okay, then it causes the close the, okay, so open the trip contacts. Okay, so this is about the wattmeter. So next we have in the induction type relay with plug setting. Okay, is the another type. Okay, so here we'll have the plug type. So this will be varied with the input current. Okay, so here we can set that 10 amperes, 2 amperes, 3 amperes. Okay, so based on the input, so the coil, so you can see the coil is connected here. So here you can see the plug is set. So which is up, okay, so at which current you want to trip the contact, okay, that will be set here. So next we having the induction cup. Okay, so induction cup, so here is the behind the contact. Okay, so it is similar to the induction disc, but here two fluxes are right angles induce the eddy current, and it's a bell shape. Okay, so bell shape is capillaries. Okay, so we are having the contact, so it's a magnetic core, and we are having the winding in that. Okay, so it put take in the poity and CTs. Okay, so we are having the four poles, that is the 1 2 3 4 poles are shown. Okay, so here bell shape with this rotate. Okay, so moving contacts we also placed in there. So here mainly the working is that, so variations in the inputs. Okay, so that is a variations in input currents. Okay, so that if the eddy currents, so mainly because of the variations current and input voltage, so this is called as the rotations. Okay, that will be given, that is connected to the circuit. Okay, so mainly here CTs and PTs. Okay, so in this type that CTs and PTs, the voltage input, that is here we can say the input signal, the input signal from CT, if they vary, that will be sensed by these variations in the rotations. Okay, so magnetic or that is the electromagnet, the induced flux is varied with that, then that will cause the eddy currents in the disc, this bell shape. Okay, that will cause in the rotations variation, that trip this circuit. So next we having the similarly, that is the shaded pole. Okay, so here shading pole is mainly at the type of the induced flux. Okay, so vary the induced flux. Okay, here also, so in this case of operation, the electromagnetic section. Okay, so this is the electromagnetic section is short circuit by means the copper. Okay, is the copper ring. Okay, that will be at this place. Next, this creates the flux around the area into the short circuit. Okay, so it is the shaded section. Okay, which lack the flux in the non-shaded section. Okay, so this will vary the input, the magnetic flux variations in the circuit. Okay, at that time, so here let's see, so in this electromagnetic index, so the relay element has the non-magnetic rope. That is the and aluminum or copper disc or cylinder. Okay, so which is the creates the magnetic flux that induces the circulating. So here circulating is nothing but eddy currents. Okay, these interacts between the fluxes and circulating the currents and generates the torque. Okay, so this generating torque causes the rotation of the disc. Okay, this is the operation of the induction mode. Okay, if the current, okay, so if the current in the sinusoidal and the iron core is assumed to the linear behavior. Okay, the iron core is the linear, the magnetic field and magnetic fluxes in the iron core are sinusoidal. Okay, so here is the one flows through the normal and other flows through the shaded. Okay, these two fluxes similar to the magnitude but different. Okay, if the same, so magnitude different, so if the same angle, that is not causes the rotation. Okay, due to the different angles only it will cause the rotation. If the both are in the same, so will causes the, there is no rotations, the it will not produce the torque. Okay, so it will not be. That's why here these fluxes in the same direction, but it in different magnitude, okay, and different angles. That will cause the rotation in that. Okay. So whenever at what situation it the trip, okay, at what situation it will trip the circuit mate. So here the input current, okay, so it will be the main coil which is connected to the CTs, okay, the CT is the input signal. So if the current, okay, so predetermined, that is the whatever the 8 watt point. So here the CT, so CT we having the different inputs, okay, so if the input current is having 60, that's the primary is the 60, so at the secondary having shows the 6 amp, okay, that is the ratio, okay, turns ratio is different in the CT, okay, so but that will be given to the CT, okay, so based upon that the current type setting, okay, will be there in this diagram, okay, at that time if the variations in the CT, okay, then the electromagnetic relay, okay, the electromagnetic, the induced fluxes is the varies, okay, if the varied in the induced fluxes, then the variations causes the trip the contacts, okay. Next we having the, so what are the features of the inductor? That's suitable for AC system. Torque does not vary with the time. Okay, so no vibration, no hint from the DC offset the low overreach. Next we having the solid state. Okay, so that will begin in the research. That's the 1940s. Okay, so first commercial there the 1950s. Okay, so that is the, here this is the another type, that is the or advanced, okay, so advance of the electromagnetic relays, okay, so solid state relay, okay, so is a electronic component, so it will provides, so these are the advanced, so in this type of relays, so we are combined, okay, so this the, you can see these are combined with the components of the electronic circuit, that is circuits which includes the resistor, capacitors, inductors, transistors, okay, so the the first they are going to deal with the only in the resistor, capacitor, inductor, but after advancement of evolutions of the electronics, okay, so try to induce, that is the uh, transistor, diodes also placed, okay, so these solid state electronic components has a similar function to electromagnetic relay, but does not have any moving component, okay, so does not have any moving component, but it increasingly, so what is the long term reliability, okay, so compared to the electromagnet still having the long term reliability. So it is based on the use of the unlocked electronic components instead of coil. So in the electromagnetic we are using the coils, right? So here we are clear that electromagnetic characteristics similarly by using the capacitor, resistor, inductor, okay. So here is the, this it will be signal, okay, so from the from analog to digital conversions also there, so we can see here, so here's the content, okay, so relay will have the 240 volts AC in the 2.5 amperes variation, okay, so inputs that, and the microprocess based, okay, let me see, so how it is working, you can see, so hit the solid state relay having the extremely fast in operation, they are having no moving parts, okay, and quick response, and they having the very reliable, okay, so you can see this the here having the input to the, okay, so how we will having the circuit, so here having the signal, that's the input signal from type from the CT, and which is connected to the rectifying circuit, that the, so whatever the CT is given, okay, that is the analog, okay, so AC current, so that will give into DC circuit the solid state, okay, so nothing but the static relay, so which will having the work in the DC, okay, that will be converted, that's the rectifier, then the electromag, okay, so we are having the transistor, capacitor, resistors combined with, okay, so based upon this variation, okay, so time setting variations will there, and input signal, okay, so how it is varied, then that will be given, so if the variations are in that, okay, so input current, then that will be connected to the varied with the circuit breaker. So here we can see the AC input from the current transformer is rectified and converted to DC volt through the shunt resistor, and here the delay time circuit, okay, the used to produce the required time delay. And if the input and resistor voltage, the base emitter transistor will be reverse bias, okay, that transfer in the cutoff step. When input is greater than the resistor voltage, okay, the transistor TR1 will be turned on and time step will be turned off, okay, that relay is activated. That is the here in the solid state type relay, okay. So that is the mainly, that is the input signal, okay, how much variations in the input signal, okay, based on that it will be 1. Next we having the computerized relay, that is a microprocessor relay, okay. So in this microprocess, okay, so microcomputer control, okay, so we can say the microprocessor. Also here the data equation transducer, okay. So mainly here in this type of relays, that's the digital protective relays. So here mainly microcontrol based also. So here the data is acquisition systems collect by the transducer. So transducer is one type of the one signaling, okay, which converts one signal to the another, okay. So his information and converts to the proper form of the used by microcomputer, okay. So it is information from CT and PT, other systems amplified and sampled at the several kilohertz, because in the here in the AC we are using only in the 50 Hz, okay, that will mark in the electronic comp. So that will be collected from the CTs and PTM, okay, that will be in the form of, and here it will work, that will be converted to the in the several here. So at by using the, that is mainly the transducer, it will be amplified, okay, that is the how much we need. The sample signals are distilled, okay. So here we are taking the, that is the unlock seed, okay, that will be how to, if want work with the computer, okay, that is a microprocessor. So we have to control with it in the form of the digital, okay, that is a converter, that is unlock to digital converter, and read the register in the microprocessor system, okay. The microprocessor use the kind of counting technique, that's a clock counting will be there, and use the discrete Fourier transform, okay, and to compare the input information with the preset limit, okay. So preset with the overcurrent or undercurrent voltages and send the command to the digital to analog converter, okay. So that is the here whatever the CDs and PDs given, okay, that will be first convert to the analog to digital converter, okay. Then here based upon the countings, okay, that will be register and it will be compared. So what are the input signal and what is the collected signal, okay. So based on that, so that will be given to the digital to analog. If the variation is there, then it will be circuit will be tripped. Is the microprocess based relays. So let's see the operations, okay. So what are the, having the digital relays, you can see. So at the relay applying the analog to digital conversion process to the incoming voltages and current. The relay analyze the analog to digital converter output and extract the magnitude of the incoming quantity using the Fourier transformation concept and Fourier transform. Okay, so mainly that is the input signal. So whatever the input signal we are giving, okay, that is the CTs and PTs, okay, that will convert on the digital form, okay, and the digital form is, there is the compared whatever the preset value is given, okay, what is the actual value collected by the CTs and okay. If the variations is then the contact, okay, the input signal is varied, then the output is at the digital to analog conversion, okay, that will be given to the at the output side, and that will be given to the trip contact. So here you can see that the CTPT unlock low fault, okay, so unlock to digital conversion, then digital closing front, and that is the input, that's if the magnitude impedance that will be compared. So here is the microprocess digital architecture, you can see unlock input, AD2, okay, discrete input system, RAM, okay, PROM, okay, communication with ports which will deal with the computer or the relay contact, okay, and discrete outputs if we will into the trip circuit. So this is the outboard the microprocess relay. So we can see the analog input system how it will be there, okay. So what is the input system, what is the output system, okay. So here if we can see the sampled signal, okay, so continuous signal, what is the uh, output signal should be having some, okay. So here's the sum. So based on that the comparison will be take place. So what is the which is collected and how it is with the input current. So you can see the preset sample. So these are styles nothing but the presets. So if the variations in the preset sample output and this out, okay, that will be then if the variation is there then that will be triple. So here's the sample sample, okay. So phasor calculations and different, okay, so which are not like that. So just we have to know about the how it is to work the electromagnetic relays, solid state relay and microprocessor. Okay students, this is about the today class.